We're going to start talking about productivity. Another differences between hardware and software here. So what happened is with productivity, this field is driven by productivity, and what drives it is Moore's Law. Moore's Law is twice as many transistors every, say, year and a half or so. It's been true for 40 years. Gordon Moore, a Berkeley alumnus, won the Alumni of the Year. He made this amazing prediction in the 1970s, and it's still true today. So what does that mean? Well, for hardware designers, the hardware designs get bigger every year. So they have to be able to take advantage of more transistors to create faster processors, and you get bigger memories with more transistors. That means with faster processors and bigger memories, software gets bigger, right? So the Moore's Law challenges hardware designers and software designers because the hardware they build can handle faster and bigger software, handle bigger software. Both of them have to get better at productivity. So we've come up with 4 techniques, and it works in hardware and software. And we'll talk about those 4 techniques. Clarity via conciseness, keeping it shorter, makes it easier to understand. Synthesis, rather than build it yourself, you're going to build tools that create it for you. Reuse, rather than everybody have to write it from scratch, we'll use code that's already been written. And then automation and tools. So we're going to automate things. So let me go over those. So clarity via conciseness. There's 2 things here. There's syntax, and often we give short shrift to syntax. It's not very hard, but it's still valuable, right? A bad syntax is hard to read. So that's one. There's 2 ways to write assertions there. Is assert greater than or equal to a comma 7. That's only hard to read and recognize. It's a little. What's the first argument? What's the second one? Where the second one, which is actually legal Ruby, as you'll see, is a dot should be greater than or equal to 7, is a lot fewer characters and more natural. So that counts, right? That counts. Easy to read matters, even if it's syntax. The big thing people talk about of conciseness is raising the level of abstraction. So if we go through this historically, that pretty early on in computing, and within 5 years after the first commercial computer, they had invented high-level programming languages because it was so tedious. That raised the level of abstraction. Later, many years later, automatic memory management. So as we have in Java versus C, that became another productivity enhancer. Certainly, it could be more efficient if you manage memory yourself, like you do in C. But boy, you could be a lot more productive. You won't have those bugs if the system will do it for you, like in Java. More recently, scripting languages, which have ideas like reflection, they can look at programs and examine themselves, and metaprogramming, where you can do program synthesis, are ideas about basically language-oriented ideas of raising the level of abstraction. Software synthesis. A specific example, you'll see a lot of that in this course, but a specific example that you might already know about is the classic one is BitBlit, which is to try and do a little code generation, and it's because that's BitBlit, it's trying to update an image on the screen, and one way to do it and get it go fast was rather have a conditional loop right in the middle of the loop. You generate different versions for different images. And we'll talk about several examples within the Rails environment, but also a programming example of kind of a future direction things is involved with program synthesis, software synthesis. Reuse. This is one of the big things that people want, is to reuse code rather than rewrite it. And a bunch of ideas have been invented to get reuse in historical order. Almost from the very beginning, when people first built a computer, they realized they would like to have functions or procedures that they could use repeatedly. And shortly after that, they said, well, if we're going to do that, let's have some standardized libraries. Rather than I'll reuse my modules in my program, somebody builds these libraries and we'll use them. It's been kind of amazing that standardized libraries haven't solved all the problems in the world, right? Nevertheless, somehow library technology isn't quite right, and the libraries don't work, so I have to write it myself or make changes to it. But that's been an attempt to do reuse. So go at a bigger scale, raise the level of abstraction to get greater reuse. Object-oriented programming was invented to collections of tasks, and then kind of a very higher level thing is what's called design patterns, which we'll talk about, where you reuse a general strategy even if the implementation varies, and we'll talk about design patterns. This actually comes from the architecture field, where they talk about design patterns of buildings, but there's some relationship with software architecture, and we'll talk about that. Automation and tools. I think one of the fundamental beliefs is we can do this. This is what we do. We're tool builders as a field, right? we see something tedious and manual, and we're going to figure out a way to make it, replace this tedious thing and do a new tool to make our lives better. Maybe certainly faster and ideally improve the accuracy. So Make is an example of that. Make was invented by Stuart Feldman 40 years ago when people used to have to remember to write everything down and compile everything. You just compile everything over and over again. He said, well, why don't we invent a tool to do that for us? It can remember which things you have to compile, which things you don't have to compile, and put it all together. Now, what's wrong with new tools? Well, how do you know if it really works? Maybe the user interface is lousy, it's unreliable, and there's often many of them. So how do you deal with that? So we think, although that's the downside of new tools, we think one of the skills that you need to have to be a good software developer is it's easy for you to learn new tools. Oh boy, a new tool. You don't say, oh God, a new tool. I don't want to learn another tool. Oh boy, a new tool. It could make my life better. So you're going to get lots of chances to do that in this course. Cucumber, RSpec, Pivotal Tracker, you're going to hear these raised a lot. These are examples of tools. Now the good news is for you, you don't have to worry about the picking problem, right? We're going to pick them for you. We're going to kind of guarantee they're good. You're going to have to acquire the skill to decide whether a tool's a good one or not. But you're going to have to learn a lot of tools in this course. It'll be a good skill to pick up. And but we'll point out the good ones. I think of the main use of high-level languages is the raise the level of abstraction, the clarity of your conciseness. It can help with reuse because it's easier to, if you're dealing at a higher level of abstraction, it's easier to use it. Okay, but what I wanted to put in was this, in case people went with copy and pasting is a good idea. So Andy Hunt and Dave Thomas, this is what's kind of cool about this Agile stuff. It's not all that, at least from our perspective, it's relatively recent. They said every piece of knowledge must have a single, unambiguous, authoritative representation of the system. And they captured in that phrase, don't repeat yourself or dry. You don't want to find many places you have to apply the same repair. So don't copy and paste. But basically, besides don't copy and paste, there will be lots of places that you'll end up seeing, well, this is in separate places. There's some way I can combine that together. This is one of the big themes of the course is drying out your code. And you'll see that and come up, we'll talk about techniques to do it.